Good morning. I'm going live a little bit early just so that the stream is going when people try to log in. Uh, for those of you watching later, I will put a picture up for when we actually go live, or whenever I actually start discussing the lesson, and you can fast forward to that spot. Yeah, I don't want to record. Uh, yeah, we are going to be in Transformers today. This is Transformers Lesson 1. Transformers Level 1, Lesson 1. Uh, Alright. Got everything open I need. We are just moments away from getting started. This first lesson is magnetism and electromagnetism. Oh my god. Uh, Sorry if y'all can hear the TV in the other room. Uh, let's see. Okay, let's go ahead and start to get started. Let's do marker. Ooh, that's gonna be big. Hmm. Starting now. This is so that people watching later can just scroll through to when I get started. Alright. Blank is a force that acts at a distance and is caused by a magnetic field. That is magnetism. So, what. I mean, that's. Everybody knows what magnets are. Uh, so, magnetism is a force that acts at a distance and is caused by a magnetic field. A ferromagnetic material is easily magnetized. Here's on page 1 of your code book, or not your code book, your Transformers book. This one right here. Uh, Examples of ferromagnetic material are iron, nickel, cobalt. Uh, there are some uh, more obscure ones. The neodymium magnets, they are a ferromagnetic material. Page 1's quite a ways into the book. Let's see. Samarium and other rare earth magnets, elements. Iron, nickel, cobalt. Alright. Your DC3 book has a list of a lot more inside of it, but those are what we're starting with. A permanent magnet is a magnet that can hold its magnetism for a long period of time. This is, yeah, that's what a permanent magnet is. A permanent magnet is a little bit more in depth, it's a magnet that, or it's a material that can hold its magnetism without an outside magnetizing force for a long period of time. So, like an electromagnet, once you take the electricity away from the electromagnet, it's not magnetic anymore. But a permanent magnet, it's like those neodymium magnets. They are just magnetized. A material is magnetic if it has organized molecular magnets so that the individual fields add together. So that is in a material. Let's change to a pen. Let's make a rectangle real quick. In a material, you have a bunch of molecules that have magnetic charges, and they're going all different directions. Whenever they get magnetized, they all get pointed the same direction, and that helps their charges add together and create an actual useful magnetism that we can observe. Alright, blank is magnetism produced when electricity passes through a conductor. Electromagnetism, I've mentioned that earlier. Examples are solenoids or transformers, various other things, but it's electromagnetism. Electric motors operate on principles of electromagnetism. A strong concentrated electromagnetic field is developed when a conductor is wrapped into a coil. I believe we've talked about coils already this year. Wrapping a conductor into a coil makes the fields add together. The fields around the conductor add together and create an electromagnet with a north and a south pole. So if you go into your textbook on page 6, I'm glad I wrote that down. On page 6, you can find a chart that has analogous means the same as, which of the following magnetic qualities is the same as, or equivalent to the electrical equivalent of voltage. So which one of these is the force that pushes magnetic flux? And that is magnetomotive force. You can see on the chart on page 6 that there are comparisons to be made between the two things, between electrical terms and magnetic terms, and you can kind of compare those. It gives you a good understanding if you understand one of them. Reluctance is the opposition to magnetic flux in a magnetic circuit in a given column of space or material. Yeah, so reluctance is like resistance. It's pretty obvious. And it's how opposed a material is to magnetic flux. So if something had like zero reluctance, the magnetic field would just pass right through it. And if something has 100% reluctance or enough reluctance to overcome the magnetic field will go up to that material and stop. Magnetic field. Oh, that's what I'm smelling. Okay. Yeah, that's magnetic field intensity is the amount of magnetomotive force that exists. The strength of the So the more current you have, the stronger the electromagnetic field is. Also, the more coils of conductor that you have. Probably need to angle my camera down a little bit more because I keep doing hand stuff out of frame. Blank is measured in specific conductivity. Permeability is that's uh, how well a material it's like reluctance, but the opposite. It's how well uh, a material conducts magnetic flux. Yeah. So whenever a circuit reaches saturation, you can't increase flux lines or magnetic flux into it. You have put too much current into the material, or as much current as possible into the material, and you can't make a stronger magnet once you hit saturation. I already answered this question. Yeah, wait. If you operate a transformer at saturation, the waveforms can be distorted where they're supposed to be. Uh, the waveforms are supposed to be like that. They can actually be like I don't know. They get messed up. Uh, Probably it would have been easier to uh, look up a picture of it. Blank is the property of ferromagnetic materials where the magnetic induction of a coil lags the magnetic field. It's hysteresis. It's Hysteresis is a term that exists in all sorts of things, and that's where uh, something that should like if you think about voltage and current, it back to DC theory. If you think about voltage and current, how if you increase voltage, current also increases. That would be it would be if you increase voltage and you increase voltage and then current moves, and then you decrease voltage and then current. Like there's a uh, there's a lag there between the two things. Uh, which answer does not strengthen the electromagnetic field of an electromagnet, applying an AC rather than a DC voltage source? Yeah, that doesn't change anything in an electromagnet. All right, I'm going to wait till 9 o'clock to finish the quiz. Uh, but I am going to get off of here. At 9 o'clock, the new quiz will go up, and I will see you guys at 10:45. Just a reminder, if you did not get the message yesterday, but somehow you're here, uh, tests can be picked up today between 11:30 and 2. So they increased that window a lot, and I think that's a good thing. All right. I will see you guys at 11 or 10:45.